Welcome to the viewers. Now we discuss to find out the eigenvector of a square matrix of order 2 by 2. At first we are starting with the simple eigenvectors of a matrix of the order 2 by 2. Let us consider the matrix. Suppose A be the matrix in this way 3 2 3 2 and 1 2. How to find the eigenvectors? At first, to find the eigenvector, at first we have to calculate the eigenvalue. Let lambda be the eigenvalue of A. A be the matrix, actually of matrix A of order 2 by 2, and obviously A be the square matrix. This is the main criteria to find out the eigenvalue and eigenvectors. A must be the, every matrix must be the square matrix. Now we have to find the characteristics equation. That is determinant of A minus lambda I. That will be 3 minus lambda to 1, 2 minus lambda. That will be 0. And we discussed already in my earlier video how to find the characteristics equation and to find the eigenvalue, which imply 3 minus lambda into 2 minus lambda minus 2 is equal to 0. That is lambda square here. Minus 2 lambda minus 3 lambda, that is minus 5 lambda plus 6 minus 2, that is lambda square minus 5 lambda plus 4 equals to 0. And here if we breaking in the middle term factor, that will be factorized as lambda minus 5 into lambda minus 1. Therefore lambda equals to 1 4 are eigen values or characteristics values of square matrix A. Now we are discussing how to find the eigenvectors. The main property of eigenvector is this eigenvector, if we take xy of 2 by 2 be the eigenvector of matrix A, then it must satisfy Ax equals to lambda x, where lambda is the eigenvalue. Therefore we have to find here for the matrix A 3 2 1 2 and x, capital X, that will be, and lambda. At first we take the eigenvector corresponding to 1, that is 1 into xy. Eigenvector corresponding to eigenvalue 1, which imply for matrix multiplication 3x plus 2y is equal to 1, and another term is there x plus 2y, that will be x, sorry, here it is x and here it is y. From these two we are getting these two values. And how these two value formed, we can taking its matrix format and comparative comparison, we are getting these two values. That is 2x plus 2y, that will be 0, which indicates x plus y is equal to 0, and another is from the second equation x plus y equals to 0. So both of these two equations it is from the first taking it 1 and taking it 2, from 1 and it is from 2, we are getting these two values. Therefore both the equations converted to x plus y equals to 0. Now x plus y equals to 0, that is x by 1 equals to y by minus 1. If we take it as k, say, therefore x equals to k and y equals to minus of k. Therefore the required eigenvectors corresponding to eigenvalue, it is calculated as eigenvalue 1. Therefore eigenvalue 1 is, we calculated as x, therefore it will be kn minus k, that is k into 1 minus 1. And now we have to find eigenvector corresponding to eigenvalue. Here it is calculated as 4, that is ax equals to lambda x. Similar equations, ax is 3 2 and 1 2, xy, ax lambda is 4 into xy for the matrix multiplication, which imply that is a 3x plus 2y, that is 4x, and x plus 2y is equal to 4y, taking it equation 3 4. From 3, if we shifting this part, then minus x plus 2y is equal to 0, and that can be written as x minus 2y is equal to 0. And from 4, x minus 2y is equal to 0. Both these two equations converted to single equation, as we can write x minus 2y is equal to 0. Therefore x by 2 is equal to y by 1. Here we calculate as L, say, therefore x equals to twice L and y equals to only L. So the eigen vector corresponding to eigenvalue 4 is, it is calculated as twice L and L, that will be L and 2 1. So the eigenvectors are k into, that's a k be the any arbitrary scalar, and L of 2 1. And it is easily observable these two vectors that are linearly independent. So these two vectors are these, therefore these two solutions, these two vectors are linearly independent. These two vectors are linearly, these two vectors are linearly independent. Therefore the required eigenvector is corresponding to these two. So in this way we find the eigenvectors of the corresponding matrices, and these two vectors which we can be found and that must be linearly independent. This is the main criteria, and we end our discussion today for discussing just simple eigenvectors of the eigenvalues of order 2 by 2 matrices. And if you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.